Let's talk about how a production possibilities frontier measures opportunity cost. The opportunity cost of obtaining more of one good is a reduction in another good as the economy moves along its production possibility frontier. Let's use the graph we've been working with as an example. What happens as we increase the number of cars from 0 to 600? We go from 0 up to 600. Well, that means the number of computers is going to go from 3,000 down to 2,220. So we give up 800 cars to obtain those 600 computers. We give up 600 computers. To gain those 600 cars. We do some, just take the ratio of that. It means that we give up 1.67 computers for every car that we obtain. Now, what happens when the number of cars goes from 600 to 700? Well, now the number of computers goes from 2,200 down to 2,000. So now we give up 200 computers to obtain 100 cars. So the ratio is 2 computers per car. Well, now what happens is we go from 2,000 computers down to 0 computers. The number of cars goes from 700 to 1,000. So we give up 2,000 computers to obtain 300 cars, which is a ratio of 6.67 computers for every car we obtain in that movement. So the opportunity cost shows the opportunity cost of getting more cars is the number of computers we have to give up as we move along that production possibility frontier. Notice, as we go from moving from here to point A, we've got opportunity cost of 1.67 computers per car. A to B, the opportunity cost is 2 computers per car, and B to this intercept is 6.67 computers per car. The opportunity cost of each car gets higher as we move down and to the right on the production possibility frontier. Now, why does the opportunity cost of getting more of a good increase as we obtain more of the good? Our example we've been working with has measured computers on the vertical axis and cars on the horizontal axis, and it's been a curved production frontier. So really, whenever the frontier is curved in that fashion, the opportunity cost of another car will increase as we make more cars, and the opportunity cost of another computer will increase as we make another computer. The question is, why does the opportunity cost rise? Which is the same as saying, why is the production possibility frontier bowed in that fashion? Well, the reason is that some resources are better suited for making computers, and others are better suited for making cars. So let's think about what's going to happen. If we're producing mostly computers, we're going to use all the resources to make computers. We're going to use the resources that are good at making computers and the resources that are good at making cars. But as we move to the right and down, which resources are going to be the first ones that we're going to take away from making computers towards making cars? Well, it's going to be the resources that are best at cars and that are worst at computers. So initially, we're not going to give up very many computers to get more cars because we're going to be taking resources that are bad at computers and good at cars to make those cars. However, as we keep on moving to the right and down, we're going to move away from people who are really bad at computers or really good at cars, and now we're going to get people who are kind of good at both of them. So the opportunity costs are going to rise, the slope of that curve is going to get steeper. And as we keep on moving down, at some point we're going to be taking the only people left making computers are the people who are really, really good at computers or who are really, really bad at making cars. That means when we again move to the right and down, the loss of computers relative to the cars we gain is going to be, in the words of Donald Trump, huge, baby, huge.